Alright, so this will probably be my last video on the Ferocious Cup. Maybe not, the month's still young, but this is pretty well where I think the model will end up for this month. And so today I'm basically just going to go over incorporating the Silph API. So what is the Silph API, you ask? Good question. This is, so if you go to silph.gg and you go over to the Ferocious Cup resources, you can navigate over here to cup stats, and that will give you the percentage with the usage of each mod. And so you can check all matchups over the last 7 days, you can check victors, etc., etc. All matchups and victors over all the time for the cup. And if we go over here to the API usage, we essentially just have this URL. It'll output some JSON data. The main reason I'm going to this particular page is so that if anyone runs this model themselves, just be sure you follow this rate limit here. So only run it 10 requests every 10 minutes. They explain why you shouldn't need to get anywhere near that amount. But if you're doing like debugging and stuff, just be cautious of that. And then of course I have this cited in here. It's the silph.gg. I also include a little bit of the text explaining, the rate limit. So that way we, both you and me, do not get in trouble and make this require an API key or something. But for right now, people have been using it pretty well, from what I can see, which granted isn't much. Alright, so what does this output? Well, we get 4 tables here, and those correspond to, let me go back here a little bit. Those correspond to these 4 tabs we can choose here. And in particular, what I'm going to be looking at is all 1 week. Why is that? So the model is the most recent usage of mods, and I think a week is a pretty good time span for that, and it's my only recent time span to choose from. And I'm doing all instead of victors because you're more likely, or because you're likely to run into a mod if it's likely in the all section. The victors section, it depends on whether or not that mod wins, and that doesn't necessarily affect the chance of you running into it. So yeah, so I just read this in. In this case, we have 33 Pokemon that are here. This can vary quite a bit. Earlier in the cup, it was much larger, somewhere around 38. Now it's fairly small. You don't have as many in the 1% mark here as we used to, but that's all generalized out. So the only difference there is that it's going to take longer to run if you have more mods. Alright, and these are in no particular order as far as I can tell. I'm not really sure what order they put those in. Okay, and so basically we have a little bit of the same thing. If you saw the previous video, which I go over movesets, there's a recent change to PvPoke that has all of the output CSVs have the same moveset. So basically the change that I made there ends up being implicitly made in the PvPoke code. So we have consistent movesets across both the home and away team, which is very nice. I appreciate that. just defining the colors as usual. I had this reverse lookup table for the later cluster analysis. We'll get back to that. Let's see, basically run the same thing again. I'm generating a separate table that is the weighted team battles. So here I multiply that by the percentage of each particular mon. So you have your score times the probability that that team shows up, which implicitly assumes that the frequency of each mon is independent. That is not necessarily the case, but is the best approximation that I have at the moment for that. So we get this number of wins, which is no longer very Gaussian. This is not factoring in the weighted yet. The weighted histogram doesn't make a lot of actual tangible sense. This is only including the 33 mons weighted evenly. So we get this very triangular distribution, interestingly enough. We can do the same things that we did earlier. Again, this is not weighted yet, but we got Umbreon, Sandslash, Suicune, and then we can rank the individual mons based on their teams. And then we're going to do the same thing for score. So we've got, a top team for the evenly weighted stuff, and then top mons for the evenly weighted stuff. And then here we're going to go and look at the weighted. And so this is the interesting additions to this model. So your best team weighted is Sandslash, Suicune, Alolan, Ninetales, which is a pretty solid team. I don't think there's a huge surprise there. We do get a good amount of Alolan Marowak showing up. That's interesting because earlier it seemed to be pretty well written off. But I think the most interesting results happen in the individual mon rankings. So first of all, Minun just takes off. It's now in third place, which I think is pretty reflective of where it should be, because you need an electric type, generally speaking, to counter the waters. I think the surprising result here is that Skuntank beats Umbreon in the rankings. So that is an interesting result there. Vaporeon has dropped quite a bit. It's still above Bibarel, which dropped even further. But your top water mon is going to be Suicune here. Piloswine and Alolan Sandslash are pretty high up there. The Alolan Sandslash is a little surprising. Granbull is not far behind Alolan Ninetales, as is to be expected. And the rest of the results are fairly consistent with what we know. Alolan Marowak is pretty high up there. Aggron and Lairon are pretty good. Nidoqueen here. Nidoking a little behind. Raichu being a more accessible electric type, but not quite as good, and so on and so forth. Now this is an admittedly poorly formatted chart that maps the usage down here on the x-axis to the score, the weighted score that we get. And so Sandslash is number 1, and its usage is still 1%. Why is that? I don't think it's necessarily that people don't know that Sandslash is good. I think that this is definitely due to the fact that you have to get a Sandshrew from a rocket stop So you have to encounter a rocket stop that has a sand shrew. You got to catch the sand shrew, and that particular sand shrew has to have really bad stats, so that when you purify it, bring it up to level 25, it is still below 1500 CP. Other than that, not a whole lot of mons, interestingly enough, that are used more than they're worth. I think the exception here being possibly Bibarel. And there's not all that much of a surprise there. People like Bibarel. I like Bibarel. But it's not quite as good as its usage would suggest in the Ferocious Cup. Alright, so that's basically how the Silph API works with this model. Again, I'll go up to the rankings here for anyone still trying to determine a team, such as I am. Yeah. Alright, so one more thing we're going to look at here for this video, and I'll call it a video. Scroll through all of this stuff here, all the way down to the bottom. Alright, cluster analysis. So what is a cluster analysis? Well, let's take the simple case. The simple case being individual Pokemon. So we have our 33 Pokemon, and we have them in a table. That's 33 by 33. And that table has the score that Pokemon on the in the rows versus Pokemon in the columns, and then there's a score attached to that. So we can interpret that as saying, all right, each row is a point, and each column is a dimension. And so we've got a point in this case in 33 dimensions, and we can then say, all right, in this 33 dimensional space, which points are close together? And I'm doing what's called k-means cluster analysis. I encourage you, if you're particularly interested in how this works, to look that up. There's plenty of good online resources about that. But essentially, in the simple case of individual mons, I've got them grouped here into 7 clusters. For k-means, you do input the number. I found 7 to be a generally pretty good number. There are ways in which you can find good numbers. I've been mostly eyeballing it for now. More rigorous cluster analysis is to come. But essentially, each row here is my cluster. So these clusters can be of different sizes, as you can see. Absol here is all by himself. Alolan, Ninetales, and Granbull are in the same cluster. Not a huge surprise, considering they're both fairy types. In fact, the 2 fairy types within this meta. Let's see, what are some other surprising results? Let's see, we've got ground types here. Sandslash, Piloswine, Nidoking, Nidoqueen, and then Alolan Sandslash. Just not quite a ground type, but it's probably awfully similar to Sandslash here. We've got fire and water grouped together. Ninetales, Alolan, Marowak, Heatmore, Entei, along with Suicune, Vaporeon, and Bibarel. And then some interesting groups here. You got your electrics, but also Umbreon and Skuntank and Shelgon. And so these aren't necessarily based on typing. A lot of the clusters do tend to revolve around typing, just because that's a very obvious way of defining mons, and it does tend to change the scores quite a bit. Just to give you an idea of the variability in this, I'm just going to run this a few times. So there's a random element to k-means clustering, and so that one that I showed you is most definitely not the necessarily the canonical version. They can definitely change based on how you run them, and we can just run it multiple different times and take a look at it. Another thing that you can do with this is I can change this number of groupings to a rather high number, say 28, and then we can find which mons are similar to each other. So Suicune and Vaporeon, Lanoon and Alolan Raticate is interesting. Ninetales, Alolan, Ninetales, and Granbull, not all that surprising. Raikou, Minun, and Raichu, pretty expected there. Furt and Mightyena is interesting. Nidoking and Nidoqueen are fairly similar. Alolan, Raticate, and Houndoom. Minun and Raichu, Ursaring and Donphan, that's a new one. Normal types access to fighting moves. Donphan is ground. Yeah, and so doing so, we can find Furt and Delcatty, for instance. We can find mons that are similar to each other in the same way that we did earlier, or not in the same way, but in a similar effect to how we did correlations earlier. But this meaning we can create groups of however many mons that we want. So I'm going to bring that back down to 7. All right. You can do the same thing with teams. This one, I've had less of a chance to interpret the data for this one, but essentially I did that for 100 groups, 100 clusters for the teams, and these are violin plots. Take these distributions with a grain of salt because as there are different numbers, I had to fill in the rest of the numbers, and I did so by just populating it with the means. So that's why each of these has a generally pretty large number around the mean here. And so we're sorting by that. But I'm not sure exactly what information we can glean from this, if anything, but I'll let you know when I get there. In the meantime, we've got the Silph API incorporated into it. We've got an understanding of the frequency of Pokemon's appearance, as well as their weighted scores in accordance to the other ones. And I think that's a pretty solid addition to this model. We're moving away from having everything evenly weighted, which doesn't accurately reflect the PvP scene in general. And so I think here we have a more accurate model, and we're able to make better predictions this way. Also, as an interesting note, this changes without me changing the model. Roughly every hour or so, the API is updated, and the scores change ever so slightly or a lot depending on the usage of mons in the tournaments. So there we have it. Timeless Cup is out, and I will get a video of that up shortly as well.